D-Win in the building, you know. Como está partido and for Calcoolus. Look at D-Boy, he's ready, you know. You gotta get it on, that's how we rolling, Calcoolus. Math analysis, nah, it's Calcoolus now. My main man, a Big Sean. He does his Calcoolus.
What's Calcoolus?
You ready? You ready?
Yeah, man, I'm ready. We're ready to do this. All right. All right, class. Today I'm going to be showing you the basics of calculus. Ask me any questions you got. Go.
What's a continuous function?
Well, a continuous function is a predictable function that goes on forever, that has no breaks, jumps, or holes. You.
What are the families? These continuities and why are there these families?
Okay, there's two families, non-removable and removable. Removable only has hold discontinuities, whereas the non-removable has oscillating, infinite, and it also has jumps. Next question.
Oh, what's vague? Can you tell what vague is?
Vague is the ways you can actually express your answer. It could be verbally through word problems, algebraically, which could be through
equations,
numerically, which could be shown by boxes, and graphically, which can be shown on a graph. You.
What are the four types of discontinuities? Can you name them, describe them, and draw them?
Yes. Here's the four different types of discontinuities. Oscillating behavior. Goes all the way wiggly around. Here's a jump. It goes from point A to point B. That's another discontinuity. You got a hole. Discontinuity in the middle right here. Then you also have infinite behavior, also known as unbounded behavior. Next question.
What's the limit?
A limit is the intended height of a function. Alright, next question.
How do you read limit notation?
Okay. The way you read limit notation is the limit as x approaches a number, f of x equals L. Next question.
So, how many limits can a graph have?
A graph can have an infinite amount of limits. Next one.
Can you set up numeric tables for x equals -2, 1, 0, 1, and 2?
Here you go. Here's -2, -1, 0, 1, and 2. Should be the correct order. Next question.
When can a limit actually be reached?
A limit can actually never be reached unless if the equation, the function, is continuous. Next one.
And that's all your questions.
Alright, so anyone have any questions?
What are the pros and cons for evaluating limits numerically?
Okay, the pros is we can see a pattern, so we can actually see in a number line. The cons is we can't visually see it, and it's too time consuming.
How do you evaluate a limit graphically?
I see you guys into your homework. Okay, to evaluate a graph graphically, we got our left hand and right hand, and we're gonna see if they meet at the point. So total log, and they meet at this point right here. So that's how we evaluate the graph.
Alright, what's the difference between the limit and the value?
Well, the limit is the intended height, and the value is the actual height. So this right here would be our limit, and this part right here would be our value, because this is the point that we want to get to, but we can't get to it.
Can you draw it?
Can I draw it?
Like, when the limit and value are the same and when they're different.
Okay, so when the limit and the value are the same, okay, so this is when the limit and the value are the same right here. This is when the limit and the value are the same. And this is when the limit and the value are different. Any more questions?
Alright. If the limit does not exist, what else do you have to write?
We have to write reasons. So, for example, if there's an asymptote, we have to, not because it's infinite, or if we don't put infinite, we put it because it's unbounded and bounded. So it's important that we put reasons. Any other questions?
Can you describe when the limit does not exist?
The limit does not exist when it's a jump, where it starts right here and it goes this way. There's also a part where there's no limit when there's an oscillating, and there's no limit when there's an unbounded boundary. Any other questions? I'll have to see your whisk after and give you guys red marks for not doing your homework.
Okay. Alright guys, so any questions for me?
How do you write one-sided limit statements?
Alright, so you know on a limit there's the left side and the right side. For that, we're going to write the limit as for a function of whatever. And on the right side, a limit as function of whatever. Let's say we're approaching 0, alright? So let's write x approaches 0. If you want to go left, from the left. Alright? If you want to go to the right, this x approaches 0. Plus sign. It means it's going forward. Alright. Any questions?
Does the limit exist at whole?
Alright, the limit exists. Yeah, of course the limit exists at whole. Alright. Let's say you are going to Chipotle. I'm going to Chipotle. Chipotle right here. But the thing is, Chipotle got burned. So it's gone. The store itself is gone. The thing is, we're still trying to get to Chipotle. You have to be like on a limit. The left side wants to get there, and the right side wants to get there. So even though it doesn't exist right there, they're still intending to go there, so therefore the limit does exist there. Any other questions?
Is the value of limit and function the same?
Alright. Yeah, at times it isn't. So let's say I had a parabola right here. And the intended function, the limit's right here, right? Turns out the actual value is right here. Right, so any more questions?
What is the direct substitution method?
Alright, direct substitution method is pretty straightforward. Let's say I had been given limit x approaches 5 for function 10 minus x squared. Pretty much all it is plug in 5 to the x and solve. Questions?
What are the 4 types of answers you can get?
Alright, so the first one you're going to get is, one of them is actual on the let's say like a 5. That could be an answer. That's one answer, so it's an actual answer. And then maybe you're going to get like 5 over 0. That's undefined. That's another answer you can get. So you're pretty much done here. And let's say you get like 0 over 5. So that means your answer is going to be 0. That's one another answer you can get. And then your last one will be 0 over 0, which is indeterminate form.
What is indeterminate?
Indeterminate form? Alright, so okay. As I'll show you again, indeterminate form is 0 over 0. When we tried direct substitution, we just didn't get a number or anything else like that. It means that there's probably like a, discontinuity inside it that we have to get out in order to, get to our answer. So that's, it could be like so that means we have to go move on to different methods, like factoring out something or using a conjugate. That's all it means. It means we can't just use direct substitution. We have these other methods to go. So any more questions? Alright, I'm going to say.
First question.
Okay. What is a factoring / dividing out method?
Factoring and dividing out method is when you factor out both the top denominator and the bottom denominator, and you cancel out the common terms, and then you use direct substitution of whatever your approach is.
Alright, if you can't find the factors of something when trying to use the factoring / dividing out method, what can you try to do?
Remember in the past concept when we used the P's and Q's?
Yeah.
So, as we know, x approaches 3 makes this one equal to 0. So what we can do is use 3 and divide it out from each top and the bottom, as we know that each of them have a factor of x minus 3. So when we do that, we can factor out each side and cancel out x minus 3 for each. Then we use direct substitution and solve it.
What are the 3 possibilities when evaluating limits at infinity?
The 3 answers that we could have are: does not exist because when we multiply anything by infinity, it is so large that we cannot take the limit of it. 0, because when anything divided by when number divided by anything, when a number divided by 0 is 0 because the bottom one is bigger. And then when the exponents are equal, it's a ratio of it.
All right. What sort of asymptote exists if the limit is at infinity?
A horizontal asymptote exists at infinity.
All right.